Okay, so we are going to pick up from where we left off, and we are going to evaluate limits. At this time we're going to do it graphically. So this is what we're going to see now. So it says definition of limits. So let's just write this down and then I'll explain to you. Arbitrarily close so to a unique number L as approaches from either side. Then the limit approaches. Okay, all right. For now, let's just leave this. You can read it at some point when you have a better understanding of it. I'm going to jump right into this, the first graph that we're looking at. Okay, so if you look at this graph, it says what is. I hope you can read this. It says limit. So we're reading this graph as x. I'm going to rewrite this as x approaches -1 from the positive side. That's what we're reading in this one. X approaches -1 from the positive side. So where is -1 on the x-axis? -1 is here, right? This is x equals to -1. And where are you approaching it from? You're approaching it from the positive side. That means you're trying to read what is, as you're coming from this side, where does the y stop? So it is going to be at, what is this value of y? 2. And the same question, as x is approaching -1, but you're approaching from the negative side. So same -1, but you're approaching it from the negative side. So what's happening to my y? Y is right here. So that's basically -2. So I hope just this has kind of given you some kind of a clarity as to what we mean by a limit. What is the limit of this function at x equals to -1? From the positive side it's 2, from the negative side it's -2. Okay. If the question is asked, what is the limit of this particular function at x equals to -1, but if they don't tell you from the positive side or the negative side, because it is different from the positive side and the negative side, you're going to say it does not exist. For this to exist, both from the positive side and the negative side, it has to be the same value. That's why it does not exist. Okay, one more time. The reason why this does not exist is when you're approaching x equals to -1, when you're trying to find the, so remember you're trying to find the limit. It's not, you're not trying to evaluate, you're trying to find the limit. The limit at x equals to 1 does not exist because when you're approaching it from the positive side and you're approaching it from the negative side, they are two different values. Okay, let's keep going. As x is approaching +3, and it does not say that you're approaching it from the positive side or the negative side. That means you will look at it from both the sides. So let's go to x equals to 3. 1, 2, 3. So when you approach x from the positive side or the negative side, what do you notice? Actually, my graph from the positive side and the negative side land at the same spot. That means it exists and the value is 1, 2, 3. And what do you notice? It's an open circle. That means the value actually does not exist, but the limit exists. The value does not exist, but the limit exists. I hope that's clear. If someone asks you what is f of 3, which actually comes a little later, we'll get to that in a minute. Okay, let's keep going. Next one is as x is approaching -4. I'm sorry, here. As x is approaching -4, it doesn't tell you positive or negative, so you'll read from both the sides. So let's read this. Where is x equals to -4? 1, 2, 3, 4. What is the value of, when you're approaching from the positive side, it gives you this. When you approach from the negative side, it gives you this. So it exists and the value is 1, 2, 3, 4, 5, -5. Because, oh sorry, here I wrote it down here, -5. Because when you approach from both the sides, the value is -5, it's going to be -5. And these are no longer limits, they are evaluating. So what is the value at f of -1? It is different from the limit. You'll see why. Sometimes it is, sometimes it's not. So I go to -1. What is the value at -1? You see that there are actually two values, but one of them is an open circle. So the actual value is 2. Whereas when we see the limit as x is approaching -1, one of them is 2. The limit does not exist, but f of -1 exists. See how different things. Yeah, okay, let's read f of 3. What is the value of f of 3? 1, 2, 3. It actually does not exist because what do you notice? It's an open circle. Can you guys see that? F of 3, 1, 2, 3, right? Try to read the y value. Actually, I am wrong. It does exist. See, I made a mistake. This value does not exist, but I'm looking at this. It's about this. So 1, 2, 3, 4. It's actually 5. I'm really sorry. My mistake. It's 5 actually. Because I was so focused on this, I forgot to see this. A common mistake. And I can make this, you guys can make it, right? So just be careful if there's any other value. Just be careful if there's any other value. Okay, let's read this. F of negative 4. F of negative 4. 1, 2, 3, 4. Now you're just evaluating. What is the value at negative 4? It's this value. And it's a closed circle. So it very much exists. So it's negative 5. Alright, so that's how you're going to do that's how you read your limit. Now let's do the next graph. So I'm moving on to B. And limit of this graph as x is approaching 1 but from the negative side. X is approaching 1 but from the negative side. So 1 is here, right? 1 is here. And you're approaching from the negative side. So here, so this is where it's going. And you're approaching from, so it will be this value. From the positive side it will be this, but from the negative value it's this. What is this? 1, 2, 3, 4, 5, 6. It's negative 6. Is this clear? From the negative, so the x equals to 1, 1 is here, but you're approaching this 1 from the negative side. So that's why it's negative 6. And the same thing, x is approaching 1 from the positive side. You're trying to find the limit. Same x equals to 1, but you're approaching from the positive side. What is this value? This is negative 4. And then what is the value of x? What is the limit of this as x is approaching 1? It does not exist because when you approach from the positive side or the negative side, it has a different value. So if you're not specifying, you're going to say it does not exist. Okay, let's keep going. As x is approaching 3, what happens? So let's see. 1, 2, 3. As x is approaching 3. So now they're not telling you whether you're approaching from the positive side or the negative side. So we have to check both. When you're approaching from this side, it is negative 2. When you're approaching it from this side, what do you see? It is negative 3. So it does not exist. Because it is different from both the sides. From the positive side, it's this. From the negative side, it's this. They're both different. They're not the same value, so it does not exist. Then as x approaches 5, there's 5. 1, 2, 3, 4, 5. Okay, 5 should have a value because when I'm approaching from this side and this side, it's the same value, and that is 1. That is 1. Okay. Now we're evaluating. Now we're not doing limits. Now we're evaluating. What is the value of of this function at x equals to 1? I'm sorry. Of this function at x equals to 1, right? So x equals to 1 is here. What is the value? What do you notice? If you run your pencil up and down the y-axis, there are 2 values, but only one of them is a closed circle. So this is actually negative 6. What is the value of f of 3? What is it? Evaluate when x equals to 3. So let's go to x equals to 3. 1, 2, 3. And again, I'm seeing 2 values, but only one of them is a closed circle. So what's this? 1 to negative 3. Can you all see that? They're asking what is f of 3. So I go to 3 and run this one. I see there are 2 values for y, for 3, but only one of them is a closed circle. And the last one on this graph is f of 5. So I go to 5. 1, 2, 3, 4, 5. And what do you notice? I run this, but this seems like only value. Right? I'm not seeing any other value. So this is actually a closed circle. So it's going to say, you're going to say it does not exist. Sorry. So I hope by doing these 2 graphs, it's kind of given you an idea of how to read a limit on a graph. Alright, and we will stop at this spot.